So I'm working on a little project here. What I got going is I got this stepper motor here, stepper motor driver. You can get these on eBay from China, super cheap. This is a TB, I think it's 6560, off-brand Arduino, and then 12-volt power supply. So what the idea is going to use this to spin an arm that's going to have a camera on it, and that way I can make some long exposures with like a sweeping view, pan view. So far this is what I got set up. The Arduino is driving this driver, and then the driver is going to this NEMA 23 stepper motor. So I just got simple code running right now. So if I go ahead and plug this in, you can see this guy start spinning. Now obviously I'm going to need it a lot slower than that. So we're going to modify the code and have this go, I don't know, 100 times slower. Alright, so I'm going to do a little math here. So what I'm going to do is I'm going to use the brake rotor from the Mustang as the big pulley, and I'm going to use the stepper motor as a little pulley to spin this contraption around. So the rotor on the Mustang is 12.6 inches, and the diameter of the pulley on the stepper motor is 0.43 inches. So 12 divided by 0.43, we get 29.3. I'm going to let this run for 3 hours to do one revolution. So 3,600 seconds, that's 1 hour, and 3 hours, we get 10,800 seconds. So we get 29.3. That's the amount of times that the stepper motor will go around for 1 revolution. So we do 29.3 divided by 10,000 seconds, and that's the number we get. And I mentioned before that the stepper motor was around 3 revolutions per second. So we'll do 3 divided by that small number there, and that means we have to make it 1,100 times slower in order to match that timing. Obviously, you know, if it's off a little bit, it's not that big of a deal. Okay, so here's the code. It's incredibly simple. All you're doing is you're setting the output on pin 8 and pin 9, and really you don't even need pin 8. Pin 8 is just the direction, and we're only going one direction. So really we're only writing to pin 9, and all you're doing is you're cycling it on and off. So here's the loop down here, turning it on every 100 microseconds and turning it off every 100 microseconds. So since we need to do it to 1,000 times slower, I'm going to change this to a delay, which is, instead of microseconds, that's milliseconds. Okay, and then we'll upload that to the Arduino, and it should slow it down quite a bit. Okay, got it all hooked up again. Got the code running. I don't even know if you can tell, but it is barely moving, which is exactly what we want. So yeah, you can kind of see it moving a little bit. So we're going to go install this outside. Alright, so I got this mounted to a beam up here. It's not exactly straight. You can see there's kind of an angle there. So I put a counterbalance, just temporary counterbalance here. Because this was, as it was moving, it would kind of drift back. See, I'm not touching it, and it's drifting back. So, even with this, it's not really helping that much, so I'm going to try and straighten this a little bit more. It was just a pain in the butt to get that up there, so I was kind of dreading that, but going to straighten it up. But everything else is working pretty good. You see there's the stepper motor. It's on the edge of the thing, and as you spin this, you see the stepper motor moves. So that should move this whole arm. Also, it hits right there. So hopefully once I adjust this, it will fix that. Alright, it's now much straighter, and it's not drifting anymore, but it's still hitting this, and it's just barely hitting the garage door opener. So I'm gonna cut this down and then just drop it a couple inches on itself. So cut it and then kind of attach it back to itself, but dropped a little. and then it should be able to do 360 no problem. Okay, it's plugged in. All the wires are jumbled up and zip tied together, and it is moving very, very slowly. Now let me see if I can stabilize this camera. See if you can see it. If you look at that wire, you can see that it's barely moving. So yeah, that's exactly what we want. We'll get the camera on the end of there, and then I'll show you guys some time lapses when this thing is going. So looking back at the videos, I realized I didn't really explain what I did here. So this is obviously just a bunch of 2x4s and pieces of wood. I like to use 2x4s, to make projects like this, because they're just like one-off things. 2x4s are super cheap, and you can kind of make them into anything you want. So what I have this little piece of wood here that's got a hole cut out in it for the stepper motor. So I just kind of drilled some holes, cut out that slot, put the stepper motor in there, and then this blue bungee cord right there is actually providing. It's on an axis over here. So it's kind of providing that force onto the rotor. So it's there's some friction there that causes the gear to turn the rotor. This arm is attached. I actually used the bolts in there to attach this, and got some lug nuts that are holding this all on. The counterweight ended up being a permanent solution as usual, but everything is working really well. It's actually so far quite reliable. I got some additional bungee cords up there, just so that if this thing does, like if any of those screws fail or I accidentally bump it, these will at least hopefully hold on to this and it won't come crashing down onto my head. So kind of just like a little safety factor there. But yeah, added the camera and a couple of pieces of wood just in case this whole thing falls. I don't want to destroy my expensive camera. So the first thing I'm time-lapsing right now is creating this platform. So I'm leveling these pieces of wood, and it's basically going to create a floor that's perfectly level. That way I can build the frame and I have a good reference point, and make sure that everything is straight. So I'm going to be finishing this up, putting these pieces of plywood on here to create the rest of the floor. And once I get that done, I can start building the frame. So I'll show you the rest of the time lapse with this going. I did have to make a couple adjustments throughout it, so it's not a perfect time lapse, but it's just the first one of many. All right, thanks. Bye.